Let's talk about atomic structure. First, we should talk about what an atom is. And an atom is the smallest particle that still retains the properties of that element. So an atom of gold is still shiny, and it still conducts electricity, and it still has all the properties of gold. In fact, these atoms determine the physical and chemical properties of that substance. So the way the parts of the atom are put together determine everything. The earliest atomic theories thought that an atom was indivisible, meaning that it couldn't be broken down into smaller parts. But we now know that an atom can be broken down into smaller parts, and we know about the proton, the neutron, and the electron. In fact, there's actually been more research that shows we can break those down even smaller. So the subatomic particles that we're going to talk about are protons, neutrons, and electrons. The symbol for proton is P with a superscript positive sign, because a proton has a charge of +1. Proton also has a mass of 1.67 times 10 to the negative 24th grams. That means this number has 23 zeros between the decimal and that 1. It's an extremely small number. So instead of writing that out every time, we say that a proton has a mass of 1 AMU. An AMU is atomic mass unit. 1 AMU is equal to the mass of 1 atom of hydrogen. Hydrogen typically has no neutrons, so it's basically the mass of 1 proton. For a neutron, we use the symbol N with a superscript 0, because a neutron has no charge. A neutron has a mass of 1 AMU. A proton and a neutron are pretty much the same mass. For electron, we use the symbol E with a superscript negative, because an electron has a charge of -1. But an electron has an extremely tiny mass. It would take 1,840 electrons to equal the mass of 1 proton or 1 neutron. So when we are finding the mass of an atom, we are only counting protons and neutrons. The mass of the electron is so tiny it just doesn't make a difference. It's like if you weigh yourself with your socks on or your socks off. It really doesn't change anything because the socks have very little weight. Let's talk about where these particles are inside of an atom. In the nucleus of an atom, we have these neutrons and these protons. Outside of the nucleus, we have these electrons. And this picture shows this atom drawn in the Bohr model, where the electrons are in these perfectly concentric rings around the nucleus. And we know now that that's not the most accurate model, but it does give you a good idea of concentric energy levels where electrons get further and further away from the nucleus.